Hello, my name is Jonathan Schneider. I will be presenting our Data 222 semester project. This project was done by myself, Isaac Compton, CJ Wenham, and Anthony Payne, and we use the Chicago Energy Usage Dataset. So briefly, to go over the dataset a little bit, this data was collected by ComEd and People's Natural Gas by Accenture. The data is from 2010 and is made up of about 80% of the city of Chicago data from about their energy consumption. And the data was broken down by households, businesses, industries, month, building type, and many other variables, but those are the main variables that are relevant to how we used the data set. Um, and then the energy usage is measured both in kilowatt hours and in therms. So first getting into how we analyze the data set, initially looking at it, um, we spent some time looking at the Excel file itself to get an idea of what the data set looked like. And we wanted to, at the beginning, we wanted to analyze it by building subtype and energy usage. Um, we weren't sure exactly how deep we wanted to dive into what other variables we wanted to include, but we ran into our first problem there because we struggled to understand the building subtype variable. It wasn't clearly defined in data or in explanations about the data set on Kaggle. Um, and because of that, we had to broaden our analysis to the building type variable, um, which still gave us good conclusions, um, but not quite as specific as a building subtype. We also decided that it would be more helpful and we could draw better conclusions by grouping the energy usage also by season. So it was already grouped by month. Um, but we decided that we thought, and we'll go into this later when we analyze our research questions, but we decided that a season would be more practical and a more helpful um, division of the energy usage. And so like I said, our final project decision was analyzing energy usage by building type for each season of the year. So now I'll get into some of our code, the cleaning process that we did, um, and and then some of our graphs and what those looked like. So first off, here is our some of our code for the cleaning process. I've got it was the same process for the thermal and kilowatt hours, um, but I've included both of them here. So our lines here, basically what they do is they remove any rows uh, with values missing in the total kilowatt hours or total thermal variable, just to make sure that those values are going to be those observations are going to be irrelevant. They're not going to give us any data. So we want to remove those, and then we also created a column or created total kilowatt hours per season values by summing together um, the total kilowatt hours for each individual month that landed in that season. And then finally, we removed, there's a lot of irrelevant columns to or variables to the um, the study we wanted to do. So just to clean up the data to make it easier to read, we remove those columns. And then next, so we graphed by building type the total kilowatt hours and total therms, um, and noticed that there were some pretty major outliers. You can see for commercial buildings, specifically for commercial and industrial, and not as much in the thermal, but definitely kilowatt hours. There was some serious outliers both in the commercial and industrial um, categories, building types, and then also for thermal, there was some outliers up here um, for the commercial building type. So to deal with those outliers, um, we decided to use a Z-score. So this code here just shows um, us getting the values needed for z-score, so the mean and standard deviation of total kilowatt hours and for thermal. And then we use a threshold of z-score of 3 and -3. So any data points or observations with z-scores greater than -3 or less than 3 or less than or equal to 3, greater than or equal to -3 were removed from the data set. And that helped a lot. As you can see, the data points are a lot more tightly grouped. And there's not quite such a disparity between the energy usage. And as we'll see in the graphs later, that's not necessarily an issue. That's part of what differentiates these building types is the amount of energy that they use. But it made the data a lot more friendly to view. This is a jitter plot, and this one was really helpful to us to see kind of where the bulk of our data points were, especially for the commercial building type. So it's clear that almost all the data points are around the same area for all the building types. A lot of them are there at the bottom, near the bottom. Clearly, there's a lot more data points for both residential and commercial buildings. So then here is, we use the LM function to, obviously we're using a categorical variable, so it's not going to have a trend line, but this gives us the kind of the mean data point. It's kind of where our predicted value will be for each building type. And it kind of tells a similar story to the jitter plot. So after we did all that, we had cleaned our data. We felt like we were in a good place. Then we made our final graphs. And these graphs here tell a story that makes sense based on seasons. For kilowatt hours, your highest usage is in the summer for all of the categories. But obviously, the energy usage itself is higher for industrial and commercial building types versus residential, and that's the same for thermal as well. And as makes sense, the thermal usage is higher in the winter because you're going to use thermal energy for heating specifically. So moving on to our research questions we went into this project with. We weren't sure if it would be more helpful to divide the data by season rather than month. And the reason we ended up going with season, as I kind of said before, there are several reasons. So one, we felt like it was more helpful for drawing broad conclusions about energy usage. Even if we did use months, I think the ultimate takeaway that people would have is that they would group them naturally by seasons anyway in their head. So that we felt like that in that way would be more helpful for decision making. And then we also feel like season is more directly correlated with energy usage than month. Specifically, if you're looking at international audiences whose seasons are correlated with different months. So a good example is Australia. This data will still be helpful to them because they'll see it connected with seasons rather than particular months when their seasons going to overlap with the same months as Chicago seasons. And then our other research question was whether it would be better to include building subtypes for more specific results. And like I said, we ended up going with this because we found the building subtype categories to be too poorly defined to help us find any real conclusions. Even if we ran with building subtype, even though we didn't understand those categories of that variable very well, we might get data that told a story, but we wouldn't know what that story was because we didn't understand the variables. So conclusions based on our graphs, our outputs, like I said, energy usage for both kilowatt hours and thermal was highest by industrial buildings and then commercial. Residential tended, and this is the interesting thing because we use means. So even though the highest energy usage was commercial buildings, like we saw in the scatter plots and the jitter plots, the mean values for was highest for industrial buildings. So average kilowatt and thermal usage was highest for industrial buildings. Commercial was at the bottom or was second, and then residential, which tended to use significantly less energy than the other two. And this is likely because industrial and commercial buildings are significantly larger on average than residential buildings. Um, Energy use per season as a percentage of a total appears to be almost identical between the three buildings. As you can see here, um, even though the numbers themselves are different, it looks like the proportions are the same between the seasons. So winter, like for thermal, like for example, winter is much higher for all of them. Then spring is second, and then fall, and then summer. And it's kind of the same for kilowatt hours. Summer, then it's close between fall and winter, and then spring brings up the rear for all of them. So proportions, even though the quantities themselves are different, the proportions look similar. Um, and kind of to revisit that initial conclusion about um, residential, like industrial being the highest, and then commercial residential. You can also see that in both the graphs here. Um, so yeah, some ideas for future research. If building subtypes were defined more clearly, it would be interesting to do a similar study by using building subtype rather than building type, and we could draw conclusions, maybe solidify that conclusion about the differences being due um, to the size or the maybe the number of rented spaces in a building. Um, the building subtype variables seemed like they could correlate to some of those things, but we weren't exactly sure because they weren't well defined. Um, Along the same story, kind of, it would be interesting to compare average house size or average stories to um, like either of those variables to energy usage to kind of like the same with the building subtype to kind of determine whether our conclusion about the differences being due to just the general size of buildings. We could see if that really is the case or if it's something else, maybe commercial and industrial buildings because it's not individuals paying for their electric bills, it's businesses. Maybe they're willing to spend more to keep their building cooler or warm it up more. Um, but if we looked at other variables in future research, we could help narrow down those conclusions. So that is all. Those are our conclusions, our ideas based on this semester project. So thank you so much for your time.